Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Repairing a Windows system involves selecting the right tool for the job based on the severity and nature of the issue. From simple file scans to full system reinstalls, technicians must evaluate the problem carefully and apply the least invasive solution that will resolve it. This approach minimizes user disruption, avoids unnecessary data loss, and speeds up the overall recovery process. The A+ certification places strong emphasis on understanding when and how to use specific repair techniques. These include system file checks, image servicing commands, system restores, and full resets, all of which appear in both real-world technical support and certification scenarios. One of the most frequently used tools is the System File Checker, accessed through the command line using SFC/scanO. This utility scans for missing or corrupted Windows system files and replaces them with known good versions. It must be run from an administrative command prompt, and the process may take several minutes to complete. SFC is typically used when a system exhibits instability, strange behavior, or persistent application crashes without clear cause. If successful, the tool logs any changes made and restores damaged files, bringing the system back to a stable configuration without needing to reinstall the operating system. If System File Checker fails to resolve the issue or cannot complete due to corruption in the Windows image itself, the next step is to use DISM, or Deployment Image Servicing and Management. This tool repairs the system image that SFC relies on by pulling known good components from either a local source or Microsoft's online repositories. The most commonly used command is DISM/online/cleanupimage/restore health. This command should also be run from an administrative command prompt. While it may take time to complete, especially if online resources are needed, DISM often resolves deeper issues that prevent other tools from functioning. System Restore is another powerful repair tool that reverts the system state to a previous point in time. This includes registry settings, system files, and certain application configurations, but does not affect personal user files like documents or pictures. Restore points are typically created before major updates or software installations, and they serve as a safety net if those changes cause instability. Using System Restore can resolve recent problems without the need for deeper intervention. Technicians should confirm the presence of restore points and evaluate whether rolling back the system is preferable to attempting individual file repairs or reconfigurations. Rolling back a device driver is often the most efficient way to fix instability introduced by a recent update. This is particularly helpful when a hardware driver update causes crashes, graphical glitches, or device failures. To roll back a driver, open Device Manager, right-click on the affected device, select Properties, and navigate to the Driver tab. If rollback is available, the option will be present and will revert the system to the previously installed driver version. This tool is commonly used after graphics, printer, or chipset driver updates that are not compatible with specific hardware configurations. In some cases, uninstalling a recent Windows update is necessary to restore system stability. This can be done through the Windows Update Settings page by selecting View Update History and then choosing Uninstall Updates. Quality updates and feature updates can both be removed if they are identified as the source of a problem. Alternatively, this function is available from the recovery environment if the system cannot boot. Knowing which updates were installed recently and correlating them to the time of failure can help technicians determine whether an update is the likely cause of a blue screen or boot loop. The Windows Recovery Environment, or WinRE, is a bootable interface that provides access to critical repair tools when the operating system cannot start normally. WinRE may launch automatically after several failed boot attempts or can be accessed manually using installation media. From this environment, users can choose Startup Repair, access the command prompt, perform System Restore, or enable Safe Mode. Familiarity with WinRE is essential for recovering systems in non-bootable states and allows technicians to repair issues without relying on third-party utilities or full reinstalls. Reset this PC is a feature within the Windows recovery settings that reinstalls the operating system while offering the option to retain or remove personal files. Choosing to keep files will preserve user documents and media while still removing apps and returning system settings to defaults. Choosing to remove everything performs a complete reinstall, similar to factory reset. In both cases, this method eliminates the need for external installation media and provides a convenient path to recovery when troubleshooting tools fail to restore system stability. Technicians should always ensure that important data is backed up before proceeding with a reset, even if files are to be preserved. To illustrate a typical support scenario, consider a user who reports that their system begins freezing shortly after a recent update. Running System File Checker reveals no integrity violations, indicating that system files are not the issue. The technician proceeds with System Restore, selecting a restore point from before the update was applied. Once the restoration process completes and the system reboots, stability returns and the freezing behavior stops. The technician then advises the user to delay future updates until they have been tested in the environment, preventing a recurrence of the issue until the update is validated. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. An in-place upgrade, also known as a repair install, allows technicians to reinstall Windows over an existing system without erasing user files, applications, or settings. This method is often used when System File Checker, DISM, and other tools fail to resolve persistent system corruption. The process involves downloading the Windows installation ISO and running setup from within the operating system. During the installation, users select the option to keep their personal data and programs. Once complete, Windows is effectively rebuilt without the need for full reconfiguration. This method is especially useful when troubleshooting complex issues that affect core system functionality but do not require a clean slate. A full system reimage goes one step further and involves completely erasing the existing installation before deploying a clean operating system image. This image may come from a standardized corporate template or a clean installation source. Reimaging is typically used in cases of severe malware infection, system-wide corruption, or when preparing a machine for reassignment. This process requires that all critical user data be backed up beforehand, as everything on the system drive will be erased. Once reimaged, the system must be reconfigured, updated, and reconnected to the domain or workgroup if applicable. Reimaging offers the benefit of a fresh start, but is time-consuming and requires planning. In addition to built-in Windows tools, technicians may use third-party repair utilities or manufacturer-provided diagnostics. Original equipment manufacturers, or OEMs, often include recovery environments that provide options for component testing, system cleanup, or factory restores. Other utilities may focus on diagnosing memory, hard drives, or file system structure. Some third-party programs offer registry repair, malware removal, or startup optimization. These tools should be selected with caution and must always come from reputable sources to avoid introducing additional risks or unwanted software into the environment. The startup repair utility found in the Windows recovery environment scans the system for issues that prevent successful boot. It checks for missing or damaged boot configuration data, corrupt registry hives, and critical service failures. When launched, it attempts to automatically repair the problems without affecting personal data. If successful, the system will boot normally after the process completes. If unsuccessful, the technician may need to escalate to command line tools such as bootrec, or move toward more aggressive recovery options. Startup repair is one of the first tools technicians use when facing a system that fails to load past the splash screen. A common user complaint involves a black screen after login, where the user authenticates successfully but is met with a blank display. This may indicate a display driver issue, a corrupted user profile, or a problem with the Explorer process. The recommended first step is to boot into safe mode, which loads minimal drivers and services. From there, the technician can update or roll back the display driver, or launch Task Manager to manually start Explorer.exe. In many cases, resolving the issue does not require a reinstall, but instead involves addressing a simple driver or profile misconfiguration. When users experience application crashes or erratic behavior, a clean boot can help isolate the cause. This process involves disabling all non-Microsoft services and startup applications using msconfig, or the System Configuration tool. By rebooting the system in this stripped-down state, technicians can determine whether third-party software is interfering with system operations. Services and applications are then re-enabled one by one until the problem reappears, helping to identify the specific conflict. Clean booting is especially helpful when dealing with compatibility issues after software installations or driver updates. Registry repair is an advanced troubleshooting technique used to correct misconfigurations or corruption within the Windows registry. The registry controls nearly every aspect of the operating system and installed software. Editing the registry should always be approached with caution, and technicians must back up the registry before making any changes. Windows includes the registry editor, but third-party tools may also provide automated repair functions. Registry edits are typically reserved for situations where specific, documented fixes are available and when no other repair methods have succeeded. Creating and using recovery media allows technicians to perform repairs even when the operating system fails to load. Recovery media can be written to a USB drive or DVD and includes setup files or a full recovery environment. These tools can launch command line utilities, reinstall Windows, perform startup repair, and access backup images. Microsoft provides a media creation tool that makes it easy to generate recovery media for use on any compatible system. Having this media ready is essential for field technicians and support teams working in environments where internet access or bootable systems are not guaranteed. Restoring from a full system backup is one of the fastest ways to return a computer to a working state. Backup images capture the entire disk structure, including the operating system, installed applications, user data, and settings. When restored, the system is exactly as it was at the time of the backup. This method is ideal for disaster recovery or rapid recovery after failed updates or malware incidents. Of course, this strategy depends on maintaining current and complete backups, which must be stored securely and tested regularly to ensure their integrity and usefulness in emergencies. In summary, Windows repair techniques range from lightweight tools like SFC and driver rollbacks to full reimaging and system restoration. Technicians must know how to choose the appropriate method based on the severity and cause of the issue. The goal is always to resolve the problem with minimal disruption, preserving data and configuration wherever possible. On the A+ exam, repair techniques are tested through scenarios that simulate real troubleshooting environments. Understanding the function, purpose, and sequence of these tools is essential for passing the exam and for providing effective technical support in real-world situations. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.